Excellent. Well, why don't we start? So, hello everyone, and bonjour tout le monde. Thank you for joining this presentation hosted by the Alberta Center, and also thanks to Gordon for setting up this link. For those who don't know me, my name is Bob Koshtabida, and I'm the current chair of the Alberta Center. I'd like to acknowledge that since I'm in Devon, I'm on the traditional and modern day territories of the Kiskayous and Massicosich nations and within the homeland of the Métis. I recognize that we all work in different places, and that you therefore work in a different traditional Indigenous territory. I encourage you to take a moment to reflect on that and acknowledge it. Our speaker today is Dr. Julian Brimelow. Julian provides technical leadership as the executive director of the newly formed Northern Hail Project at the University of Western Ontario. Prior to his position, he was a physical sciences specialist with Environment Canada for 8 years. He has over 20 years experience studying thunderstorms and high-impact hydrometeorological events. Dr. Brimelow is an adjunct professor in the departments of Civil and Environmental Engineering at the University of Western Ontario and in the Environment and Geography department at the University of Manitoba. He's participated in multiple research programs and has published extensively in the peer-reviewed literature using a variety of specialized data sets. And with that introduction, the floor is yours, Julian.
Thanks very much, Bob. Good afternoon, everyone, and thank you for taking time out of your day to attend this talk. I hope you find it interesting, and as well, I found it very interesting when I, for the first time, got to start delving into these Alberta Hail Project data a little bit more. So I'm just going to stop my video here. And today I'm going to be speaking about hail in Alberta, past, present, and future. And while I'm focusing on Alberta, just keep in mind what I'm talking about today is also part of a much bigger picture when we're thinking of the Northern Hail Project and what we're going to be doing nationally in Canada. I also want to acknowledge that the first part of this talk was primarily based on work done by Dylan Painschaup-Nimi and with the help of John Hanasek and Ron Stewart at the University of Manitoba. So I saw Terry was on the call, and you'll probably recognize the top right-hand graphic, and Bob and Bill will recognize the top right-hand graphic. Today, for those of you who don't know, I'm going to be talking about research of a hail alley, which is an area, it's not, it's a diffuse area, but it's roughly between Edmonton and the High River. And it's known for its damaging hailstorms, notoriously known for its damaging hailstorms. And the most active region for hail is typically, in most years, between Red Deer and Calgary, along the foothills of the Rocky Mountains. And in this area is where all the ingredients come together for a high incidence of thunderstorms, and there also are atmospheric conditions that favor hailstorms. The storms on most days typically develop over the foothills and then intensify as they move eastwards into deeper moisture. And the area has a high population density and extensive agriculture. So that's something we have to keep in mind. Obviously, that means there's a lot of infrastructure and targets that can be damaged by hailstorms. And for that very reason, it's a topic of much interest. We have a very short but intense severe thunderstorm season here. Things usually start ramping up in late May, early June, but the real severe thunderstorm season only gets underway in mid to late June, and then peaks in July, and then rapidly declines later in August. But that doesn't mean we don't get hailstorms in September. We've had some bad hailstorms in September as well. And this area also includes the former study area of the Alberta Hail Project, and that's what I'm going to be speaking about today. So this is going to be the first half of my talk, is the past and present. For those of you who are involved in the Alberta Hail Project, you'll recognize some of these pictures. I really wish I had a van like the one on the top left here. I think we could do great work with something like that, but I'm still have to speak to Bob about how they avoided writing that ban off during the course of the project, or maybe they didn't. And the present part, over the last decade or so, social media has become an important part of reporting severe events. And after the Alberta Hail Project stopped, Environment Climate Change Canada became the go-to source for hail reports, which they have several databases, which I'll speak about too. So that's the past and the present. So let's go to the past quickly here. So the Alberta Hail Project, it was operated over 2 time windows between 57 and 73. There was a short break, and then they continued operating through 1974 to 1985. They were primarily research-driven and data-driven. So every year they mailed out about 20,000 hail cards to people, which you can see on the bottom right here is an example of a hail card that's been completed. These were then mailed back to the Alberta Hail Project, where they were entered into a database. Usually about 10 to 20% of the farmers would respond over the project area, and that yielded an average of about 1 observer per 16 to 32 kilometers squared. They also conducted surveys, telephone surveys, to solicit hail reports, and that resulted in even higher observation density of about 1 report per 3 kilometers squared. And then some folks like Jeff Strong also operated hail pad networks during the course of the project. In this data analysis, reports within 30 kilometers and 30 minutes of each other were considered to be an event. And the report with the largest hail size was taken and considered the largest for that particular event. So that a bit of aggregation going in and data analysis that I'll be showing you. There were 66,000 hail reports in the archive that we looked at and that Dylan looked at, and over 17,000 hail events. Originally, the data were archived in a format that wasn't terribly user-friendly, and the data weren't georeferenced in a form that we could use in today's tools that we have access to, like ArcGIS, for example. So Sandra Sorchuk needs a lot of credit because she took the initiative and the time to digitize the data and convert the original geolocation coordinates into lat longitude pairs. And this immediately opened up a huge avenue of research for us because we could plot the data on maps. We could do a whole lot of things with them that previously was not possible. And I've got a link here at the bottom, but yeah, really a hat tip to Sandra for taking on this initiative. So the post-Alberta Hail Project era, we'll call it, was approximately from 1982 to 2020. We accessed those data through several ECCC databases, and those databases were constructed by merging hail records from various sources within the organization. The focus of ECCC is obviously high impact weather that's going to affect folks out there, so lives and property. So their focus is more on damaging and severe hail reports rather than capturing all of the hail reports. And you'll see the impacts of that just now. The ECCC database also solicits hail reports through phone calls, and they also leverage social media to collect data. Now, for the ease of comparison in this talk, the hail sizes in the ECCC database were binned using similar size ranges as those used by the Alberta Hail Project. The Alberta Hail Project had several classes. There was shot size hail, which is less than 5 millimeters, MP size hail, grape, walnut, golf ball, and greater than golf ball. And we applied the same hail event definition criteria to these data as we did with the Alberta Hail Project data. So just to do a sanity check and look at the hail size distributions, here I'm looking at the percentage of reports. So it's a relative measure. On the left, we have the Alberta Hail Project. On the right, we have ECCC. Now, keep in mind that the size bins here are a little different. But what we notice is that both distributions show a decline in the frequency or contribution of larger hail to all hail events for both data sets. What you don't see here, but you see if you look at the hail counts or the hail event counts, is that there was a much lower number of hail reports for non-severe hail in the Environment Climate Change database than there are in the Alberta Hail Project data. And the relative frequency of low and high-end severe events was much higher in the ECC data, but that's probably because the contribution from the smaller hail was so much lower. But here, important thing to note is that, especially for the Alberta Hail Project data, we see this nice, call it a gamma or exponential distribution, which is reassuring. And in the ECCC data, we also see something similar. Now, once you start looking at these data, because we have the time and date of every hail report, we can look at the frequency by the day of year, for example. So on the left here are the Alberta Hail Project data. So these are the number of hail days per day over the period of record. There's about 24 years in the Alberta Hail Project data and 39 years in the ECCC data. And you'll notice a couple of interesting things here is that if you look at the Alberta Hail Project data, and I've drawn this fit here just to guide your eye, and then overlaid on that is the ECCC curve, and the same on the right-hand side here. You'll see that the Alberta Hail Project data, they start a bit later, but they didn't start before the 1st of May collecting data, so that explains that. And they also didn't go beyond the end of September for collecting data. But you'll see the number of reports ramps up quite a lot more quickly than it does in the ECCC data. The plateau is a bit lower, but not much. And then the tail is longer. And I think part of the reason for this longer tail here is that these are probably more small events, which weren't really recorded as much in the ECCC data as they were in the AHP data. So the AHP peaks activity earlier and the peaks broader than that in the ECCC data, and the season extends into September. And it's, like I said, the AHP data increases more rapidly early in the season, or the number of hail reports does. You could look at interannual variability, again, AHP on the left, ECCC on the right. Now, these are the number of hail events on the same scale, just for comparison, so you can see how many more hail events there are in the AHP data compared to ECCC. And even the Alberta Hail Project was focused on that area. You saw the study area earlier between Edmonton and Calgary. The ECCC data are for the entire province. So even though it's incorporating a larger area, the report numbers are still much lower. So you can see here that we all know this is large interannual variability. This time last year, we were having a really brutal severe storm season. And by that, I mean very few severe storms because there's a ridge dominating the circulation. This year, the switch has flipped and it's a very different picture. And you see the same interannual variability in the ECCC data too. And you'll note that some years really stand out as being, slumps like the 61 here and 2002 over here. And these were drought years. So you can see the impact of hydrological events as well. If you look at the data, I don't have time to show you everything today, but if you look at the data more closely, at least in these data, there were no clear trends in the annual hail events for any of the size categories. Now, what gets really interesting is you start looking at the spatial distribution. Now, remember, until recently, we couldn't do this very easily with the AHP data. We could do it with the ECCC data because we had latitude, longitude coordinates for all the hail reports. But here, obviously, I wanted to make a heat map here, but I ran out of time. But you can see there's obviously a lot of hail reports over the Alberta Hail Project area, as one would expect, with all those hail cards going out and telephone surveys. You'll even notice that there were some reports from outside of the Alberta Hail Project area. But what's interesting here, if you look at the ECCC reports, is that you can see the roads. If you took away these roads, you'd be able to see the road network. And you can also see the urban centers. So there's a clear link there. Both data sets have very few reports west of Highway 22, which is the highway that basically marks the western boundary of the agricultural cropland in this part of Alberta. Now, if you look at the data a bit closer and you calculate the distance from a hail report or event to the nearest highway or to the nearest urban center, you'll notice that the Alberta Hail Project events are 30 or 45% farther away from highways than the ECCC events. And for 6 severe events, that increases to 65%. And if you're looking for towns, the Alberta Hail Project severe events are 70% farther away from towns than the ECCC reports. And again, about 65% for significant severe reports. So that really shows you what we were seeing in this previous slide here, how the ECCC data are more tied to places where people are traveling. It might be an indication of the advent of storm chasing and people chasing storms and reporting that way. And just, you know, people in areas the towns that are situated along these highways. Now, the one thing that Dylan didn't do was he didn't dig into the data in terms of the characteristics of the hailstones. So that's something I did this past week. And it's interesting. For each hail report, there are a whole myriad of that characteristics that are recorded. Was the hail soft? Was it hard? How was it covering the ground? If so, how deep was the ground covered? What was the largest size? What was the most common size? Was there lightning? What was the estimated wind speed? Now, we don't have these data for every hail report, but we do have them for thousands, you know, multiple thousands reports. And if you look at these data, not surprisingly, about 86% of hail events in this database were associated with the lightning report in the hail card. That's a bit lower than I would have expected, but it also, obviously, most hailstorms are thunderstorms, obviously, and they're producing hail. What is a little interesting is that as you go to larger hail sizes, there's an increase in the percentage of events with lightning. It increases quite rapidly from shot size to grape size hail, and then it tends to plateau after that. But the highest occurrence of hail is about 88%. And that's occurring for golf ball. And I think it was for, what was the other category here? Walnut. There was a high incidence of lightning, especially. So not entirely surprising, but kind of neat anyways. This is the days before we had the Canadian lightning detection network. And it might also be relevant to some work I'm doing with Dominique Brunet at ECCC on using Bayesian theory to infer hail occurrence using lightning data as a proxy for hail. So if you look at the shapes of hail, now remember these farmers weren't trained. They're just citizen scientists essentially, but they did try and categorize the hail shape as conical, flat, egg, or spherical. And then there's another category here, other. Now, again, 70% of the hailstones are classified as spherical. No surprises there. Probably an equal split across all the remainder of categories. But if you start drilling down into the sizes, you'll see pea-size hail is predominantly spherical. And then if you go up to greater than the golf ball, the relative contribution of spherical drops off quite a bit. And we have an increase in the occurrence or relative frequency of, what am I looking at here? Flattened hail and for other. Now, I think what this other here is, and this flattened, it means that as hail becomes larger, and Laura Shedd showed this in a recent paper she published using the IBHS data out of the States, that the hail tends to become more prolate ellipsoids. So your minor axis becomes smaller while your maximum axis increases. So, and as your stones become larger, they've also begun to have lobes on them and be knobbly. And so they might not have been sure how to categorize the hail. But there's definitely an increase towards the frequency of other categorization and a decrease in spherical as you go into larger hail. Now, the surface texture is something that also was reported. So there were just 4 categories here: smooth, raspberry, so that's just kind of lumped, but no marked surface features; knobbly, which would maybe include some smaller lobes; and then other. Over 60% of hail classified have smooth surfaces according to this data. But it's, again, if you drill down by size class, you'll see that 70% of pea-size hail is smooth versus only 20% for greater than golf ball. And this is important because changing the surface texture of your hailstone, it affects the fall speed, and it has a whole bunch of knock-on effects in terms of the microphysics and growth within the clouds. And it also affects the ventilation coefficient and how rapidly you can remove heat away from the stone. And the more structure or roughness you have to your hailstone, the more efficient it is at removing heat, increases the ventilation coefficient. So the percentage of hail with knobbly surfaces increased from 15% for P to over 42% of all greater than golf ball hail reports. So again, nothing surprising, but given that these was, just farmers doing this, some very interesting stuff coming out. Something that I'm particularly interested in is the occurrence of wind and hail at the same time. Now, again, I think this was done subjectively. Bob and others who are involved in the program could probably correct me, but there were 4 categories, light winds less than 15, moderate winds 15 to 40 kilometers per hour, strong winds 40 to 65 kilometers per hour, and greater than 65 kilometers per hour. I think that's about gale force in the old terminology in the dark brown here. And you can see that most of the hail events were associated with light winds, and there was a steady decrease for stronger events. But when you drill down, you find that the relative frequency of gale force winds increases a lot in size, from about 5% for P events to 20% for greater than golf ball events. So this isn't good news, because it means the odds are that the larger the hail size falling, there's going to be stronger winds associated with it. And of course, that has 2 impacts. It increases the impact energy because of the energy imparted on the hailstone from the wind. And it also means that surfaces that would ordinarily have been protected will no longer be protected. So I found this quite interesting, actually, and I hope to corroborate it using independent data with the Northern Hail Project. So just to summarize, the digitized Alberta Hail Project dataset is a treasure trove. There are many opportunities to leverage these data. For example, one could study hail environments using the ERA5 data. They go back to before the start of the project. There's really good agreement between the Alberta Hail Project and ECCC data, but there are also important differences. For example, the number of non-severe hail reports are significantly underestimated in the ECCC data, and the ECCC reports are biased towards highways and urban areas. So one question is, well, could we replicate what was done during the Alberta Hail Project, but on a national scale? I mean, that's what one would ideally do if one wanted to develop a climatology of hail for the whole of Canada, for example. And the truth is probably not. Canada is just too big of a landmass. It's very sparsely populated. But maybe we can use a synergy of all the new technologies to obtain a similar level of report density as for the Alberta Hail Project. And this is something that the Northern Hail Project is going to be looking into. We could use these data that we have from the Alberta Hail Project, for example, to train some algorithms based on environmental conditions to infer the size of hail, for example, and use that, apply that nationally using the ERA5 data. So that brings us to the second part, the future, and that's very simple, is the Northern Hail Project. So what is the rationale and background for the Northern Hail Project? Well, it's been almost 4 decades since the last dedicated hail research program in Canada ended. As a result, there's a significant gap in high quality and high resolution data for both hailstorms and hail. This data gap is a big bottleneck in advancing hail research in Canada, and it's critical for improving the forecasts and impact assessments for damaging hail events. And another big problem is that there's been a dearth of Canadian meteorologists, engineers, and risk modelers who have the expertise to forecast, assess, and model storms that produce damaging hail. So we need to create opportunities for them to train the next generation of scientists. And the NHPA aims to address these gaps with a primary focus on damaging hail events. We can't look at all hail events in Canada. If you look on the right-hand side there, the bottom panel is the mesh product from radar. Typically, if your mesh is indicating 3 centimeter or larger hail, there's probably severe hail on the ground. And here we have the same map, but for severe hail reports from the ECCC database, the same 3 years. And you can see that there's a lot of hail out there that isn't being reported. And this is severe hail. It's probably even worse for non-severe hail. And that means it's also for non-severe hail that producing copious amounts of hail that can also be very damaging. So the NHP is going to build on the expertise, knowledge, and momentum of the NTP. And we're going to focus primarily on damaging hail events, as I mentioned. So what is the Northern Hail Project? Well, it is a project that's designed to advance the meteorology, climatology, and impacts of hailstorms in Canada. It's being done in collaboration with a bunch of partners, the Institute for Catastrophic Loss Reduction, Instant Weather, IBHS out of the States. There's tons of great innovative research in the last decade, and other partners such as WeatherLogics out of, I think out of Manitoba. And we're also working closely with the University of Manitoba as well on this. Now, before I get into discussing this pyramid here, I just want to point out that the goal is to train a lot of students. So we're going to have 10 PhD trainees, 7 master's trainees, and 37 summer interns. And those summer interns will include high school students. In fact, we have our first high school student joining us in the pilot field program in Alberta in just a couple, about 10 days. So the approach we were using for the Northern Hail Project is to be data-driven. So we have different tasks. We identified 6 tasks in coordination with our stakeholders and partners. And for example, task 1 is looking at the hail size, amount, weight, and hail swath data. Then we'll be also looking at the fall speeds and aerodynamics of hail. We'll be doing urban and rural hail damage surveys, which haven't really been done before. There's no playbook on how to do an urban or rural hail damage survey. And we'll also be using these data to create a national hail event archive and climatology, which will be public facing. And then these data will be used to validate and drive numerical models to look at hailstorm environments and to also develop hail hazard and vulnerability modeling products. And the outcomes we're hoping are going to be of great benefit to Canadians, municipalities, businesses, and other stakeholders across the country. So as I mentioned before, we have 6 tasks. So I'm just going to go through the 6 tasks as quickly as I can. The first task is the collection and characterization of hailstones and hail swaths using ground-based and remote sensing techniques. So just to show you here, this was a picture taken yesterday. We installed our very first hail pad out, and we have a hail pad network that runs just from southwest of Red Deer all the way down to near Cremona or Water Valley. It's about 60 kilometers north-south, and it's on a staggered grid. So we hope to have it like a net to capture the hailstorms as they move, most are typically from west to east. So this is what we're using. It's a 61 by 61 centimeter pad that's about 5 centimeters thick, and it's coated with some latex white paint to protect it from the UV rays. And in Calgary, we'll be deploying a network of hail distrometers. This is a impact distrometer. It uses piezoelectric technology, and it's about 20 centimeters across. And that records the number of impacts and also provides you with an estimated hail size for each of the impacts. And collectively, those data can give you the total impact energy, which is a good measure of damage potential. And co-located with the distrometers, we're going to have a small weather station. It's an Atmos 41 from the Meta Group. This measures rainfall, all your standard meteorology parameters, including lightning. It's got a lightning detection on it, sensor on it, and also uses an ultrasonic wind anemometer to measure wind speed and direction. And these are going to be co-located, I'll show you this now, with the rainfall gauges in the City of Calgary rainfall network that they use for monitoring during heavy rainfall events. So we have about 30 units that we'll be deploying across Calgary, but there are more sites than that. And most of these are located at fire halls across the city. So we're hoping to deploy these units in more or less as best as we can mimic a grid. And they'll have be separated by about 4 to 5 kilometers when everything's done. And we're hoping to start installing those soon. But for now, for this year, we're having the pilot year field program. We're collecting hailstones in the field for analysis. So we've already made our first collection from a hail swath a couple of weeks ago. And we'll also be sampling hail swaths using a UAV equipped with multispectral cameras and in the future LiDAR. We'll be evaluating the dystrometer network, hopefully by placing some hail pads in their proximity for comparison. And we'll be developing these data, we'll be using them to develop advanced satellite detection methods to identify hail swaths. We're using data from Planet Lab, and they have very high resolution imagery over all of Canada with a revisit time of just a couple of days. And you can even request extremely high resolution on the order of 10 centimeters if they have to have, a satellite in the area at the time. And we'll also be developing radar tools for the identification of hail and the determination of hail size. So it's going to be data driven. So these data we're collecting in the field are going to be essential for driving the project forward. And we're not going to be doing it just this year, we're going to expand. So next year we'll be going into expanding to the east. And by year 5, we'll probably be measuring hail and hail swaths in eastern Canada as well. So this is the idea here. We have a hailstorm with a nice hail spike there. Somebody will be going out in front to deploy equipment. And then once the hail swath, there'll be people going in behind different vehicles. They'll be picking up hailstones and flying UAVs. And this is just a photograph of the hail collection unit that I built in my backyard. So it does look like something from the Red Green show, but we're hoping to collect hail in advance of hailstorms. And we'll also have a hail trap here. We have lots of equipment that we'll be deploying at these super sites ahead of the storm. But very importantly, we'll be going in behind and collecting hail along the hail swath and also be doing UAV flight transects across the hail swath. And we won't be doing that just the day of the hailstorm. If there was severe damage, we're going to be going back in the following days and weeks to see how the crops and vegetation have responded to the hail that's fallen. Excuse me. So task 2 is understanding the aerodynamics of hailstones and its impact potential. I know I've said this before, so I'm sorry if I sound like a broken record, but you'll be surprised that the fall speed of hail is not well known. And the reasons for this is because hail is not a sphere and it's not smooth. And that obviously affects the aerodynamics of the hailstones. And we need to come up with better empirical and theoretical relationships to describe the fall speed of hail for use in numerical weather prediction models, but also when we're testing new building codes for, say, siding or shingles for roofing. So what we're going to do is going to take advantage of the miniaturization of electronics in the past decade or so. You can now cram a lot of technology into something as big as a 2 centimeter cross sphere. And you can then place that in the center of a hailstone like this. This is a 3D scan of a hailstone that fell in Australia. And then you can create an ice replica of that using a mold. And then you basically drop that from a UAV, and then you can have instruments on the ground and high-speed photography to measure the fall speed of the hailstone very accurately. The last time we tried to measure the full speed of natural hailstones was 1979, 1980 with Matson and Huggins. And we now have cameras like this, which are machine cameras, which this looks quite big, but if you look at the metrics, the statistics here, the specs, it's just over 4 centimeters across, 57 millimeters long and 29 millimeters high. So this is actually a very small camera, but these cameras can record at very short exposures without having to use strobes, and they can also record up to 200 frames per second. We also have continuous waveform radar technology that we can use to measure the full speed of hail, and some preliminary tests have found very promising results doing that. We also want to study the effect of wind on the impact energy of hail, and also the angles. And we're going to be using hail dystrometers, hail cubes, and high-speed video to do that as well. So the third task is to develop remote sensing and on-the-ground methods for advanced post-storm damage assessment and interpretation. Like I said earlier, there's no real playbook to go into an urban area and do a post-storm damage survey. So to do this, engineers will be going in as soon as possible after a damaging hail event. This picture here is from the Calgary hailstorm. They'll be deploying UAVs to take LiDAR imagery and also just high resolution photographs, but they won't be looking exclusively in urban areas. This bottom right image here is taken from a UAV using a multispectral camera. And after some enhancements, you can see these yellow and brown areas are actually conifer trees that were damaged by a hailstorm. I think this was in Poland. So even conifers are not immune to the impacts of hail. And obviously deciduous trees are even more susceptible to hail damage. So all this will be done to conduct advanced interpretation of the wind and hail damage to trees and forests. Task 4 is going to be documenting all damaging hail events across Canada and to develop an observational hail climatology. So this isn't going to be done just using observations. We'll have to develop proxies for hail and severe hail or damaging hail using other tools other than just reports. But again, the reports are going to be critical. So we're going to do our best to detect, assess, and document new hail events. And we're doing that this summer already. You might have seen the tweets coming out, us asking information from people, and we'll show an image of a hail swath as found by radar and try and get some reports from that hail swath. We're going to develop a comprehensive new national hail climatology based on recorded hail events. And we're going to use machine vision to leverage pictures included in social media reports. Unfortunately, we get a lot of this on the right-hand side here, people holding hail in their hand. I think it's just an instinctive thing to do. Unfortunately, I mean, obviously we know this is big hail fell here, but we don't know exactly how big it was because people's hands are not all the same size. But we're hoping to try and leverage some artificial intelligence or machine vision to get a better estimate of hail size from images such as this. And then all this data is going to be shared through a public-facing data portal, similar to what they do with the NTP. They annually produce a report, and they'll have, the number of UAV surveys, the number of damage surveys that were done, or even they've used aircraft to overfly sites, and the Planet Lab satellite data as well. So the idea is that for all these events, we'll be recording data. In fact, we have an app that we use to record data on site. The interns are using that now in the field this summer. And we'll have a similar app for our HailPad network. And all this data will be recorded and shared down the road. Task 5 is understanding the hailstorm and hail swath environments and improving models for forecasting and warning of damaging hail. So here we're going to collect field data to characterize the hailstorm environments in storm mode. We're going to do this initially over Alberta by releasing wind sondes. That's right, top right over here. This is a relatively low cost system that one can use to measure the antecedent conditions prior to the formation of hailstorms. We are also going to be conducting sensitivity tests to identify the most suitable microphysics schemes in WRF, for example, and also in the Canadian HRDPS 1 kilometer resolution model. And we're also going to be validating and improving the 1 kilometer model that's being run by Jason Milbrandt at ECCC. So we're going to have very valuable ground truth data to do validation with. And the last task is task 6, but it's by no means the least important. This is very important. Our climatology, if one could even call it that in Canada right now, is not at the level where one can use it to do a proper risk modeling. So we need to develop new damaging hail hazard and vulnerability modeling and tools. And there's going to be a social science element to this. So we're going to undertake a hail hazard assessment using WRF simulations combined with hailcast. And we're going to complete storm and hail hazard modeling for Canada using NHP hail observations and undertake a hail vulnerability modeling and risk assessments for Canada using these data. And just on the bottom right here is a similar exercise that they did recently for South Africa. In this case, they use satellite data, overshooting top data, and some algorithms developed by Chris Bedka at NASA to identify threat areas for hail over South Africa. And we're going to be doing something similar for Canada. So earlier I mentioned that we're going to be collecting data over Alberta. So we're going to have a portable test bed in Alberta. This is a new initiative. So we're going to have a portable network that we can deploy in certain parts of the country for 1 or more years. And it is going to include dual pole Doppler C-band radar. It's one of the old Environment Climate Change Canada radars. It's going to include a lightning mapping array, surface weather stations, wind sondes, hail pad networks. We're going to be trying to deploy pan, tilt, zoom field cameras that are remotely operated. The idea here is that we could observe the falling of hail on the ground or observe a tornado in the distance. And we're excited to see what kind of data we can get from these field cameras. We're going to have a mobile mesonet similar to one over here on the bottom right, and much more. So we're going to be using all these data to test and develop tools to improve our identification and nowcasting of high impact severe convective storms and hail as well. So this is a very rough timeline for the Northern Hail project moving forward. It doesn't end in 2027, but right now that's our most immediate horizon. So this year we're going to be installing the Distroner network in Calgary. We've already deployed the HailPad network, like I mentioned earlier, and we have a small field team of 4 students who are out there. They'll be out there tomorrow, hopefully, if it's a severe weather day, going on a mission to collect hail over Hail Alley in Alberta. We'll also be enrolling our first graduate students in the fall of 2022. Next year, we're hoping to go to full field operations and undertaking damage surveys in urban and rural environments. We're going to continue expanding the field work from 2024 onwards. Our research window also overlaps with an exciting initiative in the States called ICE-CHIP, which we'll be collaborating on. And that's going to be back-to-back years, at least 2 weeks, where they're going to be in eastern Colorado and Kansas and southern Nebraska and even maybe Oklahoma, collecting data specifically for hailstorms. So this is a field program designed specifically for hail. In 2026, we hope our first PhD students are going to finish. And the current horizon for project funding concludes in the winter of 2027, 2028. And I think that's all I have for today. So thank you. And I'll be more than happy to answer any questions.
Thanks, Julian. That was a great presentation. I see that there are a number of questions. There's one in the chat, and Daniel Michelson has a question. Go ahead, Daniel. Okay.
He's muted.
You're muted, Daniel. Okay, I'm not sure what's going on. Maybe we'll go back to Daniel. George, Isaac has a question. Go ahead, George.
Just turning on my camera. It's nice to hear all this. I was involved in the Alberta Hail Project 50 years ago, if you can believe it, doing my PhD. One of the questions I have is, what is severe hail? I think for a wheat field, pea-sized hail can be severe, but it's not very severe in an urban environment. So maybe you could comment on that. I think impact energy is not necessarily the key variable here.
No, you make a good point. So that's why we were careful to choose the word damaging hail, because that includes events where we have, say, copious amounts, or snowplow events, they call snowplow hail events, where you have, very deep but relatively small hail collecting at the surface, which, as you say, can be devastating for crops too.
let's try Daniel again.
I could answer Edward's question in the chat.
Yes.
Edward asks, what is the make and model of the weather station that had lightning detection built in? It's a station that was developed in Europe and is currently being deployed quite widely across Africa, in fact, to collect meteorological data. So it's built by Meta Group, and it's called the Atmos 41 model. You know, this isn't a Campbell Scientific weather station, but we had to find something that would be hopefully quite reliable and would be robust in the field. But at the same time, there was a price point we had to meet. So this is the station that met all those requirements.
So I have a question here for you, Julian. If we encounter hail here, how do we report that to you?
Thanks, Bob. Yeah, that's a good question, Bob. So we do have a few Twitter accounts, and we encourage people to, you know, even if it's small hail, it's still a valuable data point. Or if you have a really bad thunderstorm and it's just heavy rain, that's also really helpful because it's a null event, right? And sometimes finding null events can be really tricky. So if it's safe, we encourage people to, if they can, retrieve the hail as quickly as possible, because obviously time is not our friend here. It's melting quickly, especially the smaller hail. And to take a photograph looking straight down with a camera on their phone and place an object next to it of known size. So a coin works really well, or a golf ball, anything that we're really confident of the size. And then to tweet that to us, and you can at us. It's NHP_reports. And you can also use the hashtag ABStorm. Or if you're in Manitoba, MB Storm, or Ontario, it's ON Storm. And those using those hashtags will pick up the hail reports.
Okay, thank you.
Thanks, that was important. We want to try and get as many reports or null events as we can and build a really good database.
See, Daniel's hand is still up, and
Daniel just Teams texted me saying his Zoom is blocked somehow.
Oh. Did he send the question?
I'll suggest it.
Thank you. So, Bob, earlier you saw the van. Do you know if that van actually survived more than one summer before, like, getting hammered by hail?
yeah, actually, we had that van running for 2 or 3 summers.
Oh, wow. Okay.
Yeah,
So
I think that photograph that we took of it was during one of the open houses when we had installed all of the equipment on that particular van during the first season.
Okay. So did you ever lose a windshield?
No.
Oh,
No, we
okay.
never, at least during my chasing days, we never really got into the very heavy stuff. I think the largest that I ever was able to go in to was walnut size.
Okay. Yeah, and I see there were white, look like cones on the roof. Were those for collecting rain?
I'm sorry?
There were white, would look like white funnels on the roof. Were those rain collectors? Just go back here.
Yeah, let me just take a look at that photo.
Sorry, these guys.
Yes. Yeah, they were, we were collecting rain, and also George can correct me here, but I believe that we were also doing some chemical analysis of the water.
Right. And what was the net made out of? Do you remember? Was it metal? Or was it like a nylon?
No, it
mesh or
was
something?
it was a nylon a meshing that one of our colleagues, Lawrence Cheng, actually had developed years and years ago. I have a question here from Olga, who says, you showed some hail data results from ECCC. Is that hail database published?
No, it's not. We've got to do some accounting here because there's been several independent exercises to go through those data and to quality control them and to, you know, create a hail event database out of the hail reports. I know I've done it. Some of the students have done it at ECCC. Dominique, Brunei, and I and a co-op student have done it, but and Dylan's done it. So we have about 3 or 4 of these data sets, or you know, in ECCC, but no one master data set. So that's something that we really need to do, is get this master data set and then publish it.
Okay, we have the question from Daniel is, are there any other treasure troves similar to the Alberta Hail Project? Where from and how can the NHP benefit from international collaboration?
I'm not aware of anything else that was similar to the AHP that was undertaken in Canada. I mean, I know in the States, they had a similar program that was very successful. But yeah, if there is anything else like this out there, that would be fantastic. But I'm not aware of anything. And as for international collaboration, we're going to be working with our partners in the States and Australia and Europe and, you know, across Canada to do this. So it's going to be a big group effort. And I don't think we can work on that. I mean, it's called the Northern Hail Project out of Canada, but our results are going to be of interest to the international community as well. So we've learned a lot from IBHS, and we're hoping that we can return the favor and you know, develop some new tools and approaches and share those with our partners as well.
Can I just break in for a second?
Yes.
I would encourage you to write a lot of papers. The Alberta Hail Project did not publish very much. They published in the gray literature, which is hard to find. And unfortunately, a lot of the great research that was done is lost because of that. So I would encourage you to publish. Sometimes your funding partners don't encourage that, but please be aware of the past history. A lot of good work was done in the Hail Project, but not much of it was published. And by the way, one of my tasks was to drive I wasn't driving, but we had a mobile vehicle which was directed in front of hailstorms. And we had the same GK 578 truck, which was used for many years and never got really damaged. We got into grape size hail, and somewhere along the line I have or somewhere in my boxes, I have a tape recording of the event, which made a lot of noise on the truck, but no damage.
Yeah, no doubt. No, thanks, George. You make a really good point. And that's something we're very cognizant of is to publish. Right now, we're in the data gathering stage, even with the Northern Tornadoes project. But we were actually just talking about this, Gregory Kopp and I, the other day, about making sure we publish and get this out there for everyone. It makes it so much easier, right? Especially down the road. So that was a good point.
Julian, this is Daryl O'Dowd.
Hi, Daryl.
I have 3 questions. I haven't actually seen you for almost 20 years since we were up at the Olds project working with Terry Krause. So it's been a while. Good to see you back in things. I've got 3 questions here. I'll cover them quick here. I see a C-band radar. Are you expecting to install that within Alberta the next year?
No, that's probably as soon as that's gonna happen is probably 2024, if I understand correctly.
Do you have an approximate location? Are you going to be planning to get in Terry's backyard, or is it going to be? Are you going to duplicate some of that radar data? I wondered, or is it going to be way off, perhaps farther downstream?
That's a good question, and that's not something we've actually decided on yet. As you know, there's a bit of a hole near Wainwright where there's very little data. Also, more tornadoes tend to develop, or tornadic storms tend to develop east of Highway 2, right? And right now there's a really good coverage between Edmonton and Calgary. There's even overlap between those two radars. So if I had to choose, I'd be saying, okay, we'll still try and cover Hill Alley, but we might also want to look farther east, to the east of Highway 2 to try and capture some of those big events. So there will be some redundancy, but the nice thing about that is we might be able to try and redo, 3D wind retrievals, for example. It's obviously doing that's non-trivial, it's tricky, but I don't know if that answers your question or not.
Oh yeah, no, that does. I was just kind of curious where it would sit relative to the other radars. Two other quick points. I was looking at your hail trap, your red-green piece of equipment.
Yes.
The van you see there, that's Hail Chase number 3, the blue one there. I was with the teams that were using that towards the very end of the program. In Hail Chase 3 and 1 and 2, the nylon funnel was deployed, and it ran through a 4-inch flex cape, flex hose inside to effectively a Coleman cooler in which we had CO2 chips, because part of the intention was to not only preserve, not only just weigh and take photographs of the samples, but also preserve them for analysis later on, including doing cross sections and other analysis, including chemistry, because we were looking for the possibility of having silver iodide as a seeding agent. Is there an intention with your group to do any chemical analysis or other like cross-sectional analysis?
Yes. Yeah, I didn't think I mentioned that. So, for example, now with this pilot project and moving forward, the focus is going to be on collecting and preserving the hail in the field. We found that doing the measuring and weighing and everything in a ditch next to the road is not great. So we have an electronic cooler or freezer. It can go down to -20, and that's in our mission vehicle, in our field vehicle, and that's pre-chilled before the event. So we'll be collecting the hail and bagging the hail for subsequent analysis. And part of the analysis right now is going to be looking for silver. Obviously, the iodide just dilutes out and it's soluble, but we're looking for silver. But we'll also be looking to do some isotopic analysis maybe in the future of some of those hailstones. We're definitely going to be doing some thin sections. And for the larger stones, we're going to be buying a 3D, either a 3D laser scanner or a high quality photogrammetry unit to create really high resolution scans of the stones that we can then use to make molds, to make replicas, or to fly in wind tunnels and whatnot.
Right. All right. Well, that's my last question. Thanks for that, Julian. The wind sondes you're using, are those SPARV?
Yes. So they don't go as high as the traditional balloon, but we think we can get up to about 10 kilometers with them. Okay.
Okay. Well, that's good to see that you're getting some actual data in the vertical in addition to simply all of the ground truthing. So that's good to see. And I presume that at some point radio sondes would be used?
Maybe if we can afford it. Yeah.
All right. Well, thanks, Julian. Those are my 3 questions, and I appreciate your talk here today.
You're welcome. Thanks for your questions. And good to see you again, Daryl.
Thank you. We have a question here from Brian Bernard saying, Julian, how do we contact you? I happen to run a wharf model simulation over prairies with hailcast. Would that be of interest to you and the NHP?
Yes. Are you running it for WMI right now? Is this a separate project?
Brian, you're on mute if you want to answer that.
Hello there. Yeah, I'm just doing it privately.
Oh, okay.
Yeah, yeah.
That's great. So I think you're using the Hailcost plugin that Becky and Conrad developed. Becky Adam-Stellan and Conrad Ziegler.
Well, the one I'm using is actually the Unified Environmental Modeling System.
Oh, okay.
It's
Neat.
put up. Yeah, it's put up by UCAR.
Oh, great.
That's what I'm
Yeah.
doing.
So to contact me, it's just J, B for Betty, R for Roger, I, M as in mother, ELO
Okay.
at uwo.ca.
Okay.
So there's
Okay.
no W missing on the end. That's what I got.
Okay. Sounds good. Okay. I'll contact you.
Thanks, Brian. Yeah, I look forward to talking to you more about
Yeah.
that.
Yeah, absolutely. Yeah. Thank you.
Great. Are there any other questions?
I think Jason had one at one point, but his hand went away.
I think that
Still-
I
Jason.
was just passing on Daniel's question, Julian. Nice talk, though.
Oh, thanks, Jason. How's the 1 kilometer coming along, by the way? Not to put you on the spot or anything.
Good. We're gradually getting website imagery. I'll contact you in a bit about this. It's progressive. Yeah.
That's great. Good to hear. Thank you.
Excellent. Well, thank you very much, Julian, for a great talk, and looking forward to reading papers in the future on the results of the project. And thanks everyone for joining us this afternoon. And with that, I will close off the session. Bye for now.
Thanks a lot, Bob. Thanks for the opportunity.
All right.
Appreciate it.
Bye bye.
Sure. Bye.
Okay, thanks. Bye-bye.